Hello all, welcome to my channel. This video is the first video in a series on data cleaning using Python. I'll be using Python 3.11, but the code usually works on other versions as well. The Python distribution tool which I'm using for these videos is Anaconda. Anaconda is a free and open source distribution of Python which is designed for data science and machine learning. It has a huge repository of many data science and machine learning packages, and more importantly, many of these libraries or packages come pre-installed when you download Anaconda. To download Anaconda, go to anaconda.com. You'll land on a page like this, and on the top right you could see free download. Once you click that, it asks you your email address. Once you provide that information, you'll get a download link and you could download the installation package. If you successfully downloaded it, you'll find an application called Anaconda Navigator in your list of applications. If you open that Anaconda Navigator application, you'll find an interface something like this. These are the different tools provided by Anaconda for different applications. We are specifically interested in Jupyter Lab. There is something called Jupyter Notebook as well, but Jupyter Lab is an advanced version of Jupyter Notebook. Now, what exactly is this Jupyter Lab or Jupyter Notebook? It is just a place where we write Python code. Technically, we call it IDE, Interactive Development Environment. Let's look at how to use Jupyter Lab and write code. After installing Jupyter Lab, if you press the launch button, it spins up a browser tab for you. Here you can select the folder in which you want to have this Jupyter Lab notebook. And then once you finalize the folder, you can click on a new notebook on Python 3 IPY kernel. This small rectangular bar you're seeing is called a cell, and here's where you write the code and execute the code. Let's write code print hello. After writing the code in the cell, you could press Shift Enter to execute that cell and go to the next cell. One more important thing is, though this particular notebook works in a browser like Google Chrome or Edge, whatever browser you have, it runs on localhost. That means it doesn't need internet. It is running on your local host on port number 8888. Let's look at the navigation options in Jupyter Lab. If you click on File, you have options to launch a new notebook or to save the current notebook. There are many other options as well. Reload the notebook, duplicate the notebook, rename the notebook, and so on. If you click on Run, you could see different options to run the code cells. For example, run selected cell runs only that cell. Run selected cell and insert below inserts a new cell after running the cell. Run all above the selected cell, run selected cell and do not advance. So all these are different options for you to explore while writing the code. Then you have kernel options. So a kernel is the main computational engine that actually runs or executes your code. Now, whenever you write code and execute it, the kernel is what actually executes it in the backend. So when you executed a cell and suddenly you realize to change the code, you can interrupt the kernel by using these shortcut options. Or you could restart the kernel or restart it and run all the cells from the beginning. So these are different options you can explore while writing the code. You can also find small little buttons on top of this notebook. These are quick menu options, whatever you've seen before. For example, if you hover over the first button, the option is save and create checkpoint. The shortcut is Command S, which is nothing but saving your notebook. Then you have insert a cell below. The shortcut is B. For example, if I am in this cell and I want to create a new cell below this, the shortcut is B on your keyboard. If I want to create a cell above a cell, then the shortcut is A on your keyboard. And then you have options to cut the cell, copy the cell, paste the cell from clipboard, run this cell and advance, interrupt the kernel, restart the kernel, and run all cells. And you have a drop down of code, markdown, and raw options here. A code cell is where we write the actual Python code. A markdown cell is where we use to format the cell to write headings, subheadings, and so on. So Markdown is a markup language which is used to format text for documentation purpose. In Markdown cells, you have different styling options. For example, if you click double hash, that is a header 2 kind of a heading. If you insert 3 hashes, then it will be header 3. Change the cell to Markdown and execute it to find the header 3. Then you have header 4 with 4 hashes and header 5 with 5 hashes. For bold font, you can press 2 asterisks on either side of the text. For italic, single asterisk on either side of the text. Bold and italic, 3 asterisks on either side of text. Putting a backtick on either side of the print statement, it looks like a code block in Markdown. Putting a greater than symbol before a text makes the text look like a quote. And to insert a link, you could put the text in square brackets and the link in parentheses next to the square brackets. So these are the basic things what we can have in Jupyter Lab. And as we go along in future videos, we could see some advanced options as well. But I think for now, this is enough to start using Jupyter Notebooks or Jupyter Lab for data cleaning, data transformation, and data analytics. That's all for this video. Thank you for watching.